Hi everyone, in this particular video we are going to discuss about logistic regression. So we have already discussed about linear regression. So linear regression basically helps us to solve regression problems. So it helps us to predict any continuous um, dependent variable. And here in logistic regression, actually we used to classify the class, like you used to solve the classification problem. So like how, let's take some example. Suppose suppose one person has some weight. So according to that particular weight, I'm going to say, okay, this person is going like obese or not. So obese or not obese. So this type of problem I can solve. And another example I can give you, supposedly we are getting emails, right? Lots of emails we are getting. So we are in that particular email we are also getting spam or not, like non-spam email. So I can classify according to the historical data. I can classify, okay, this particular email is going to be not spam or spam, right? Not spam or spam. So this type of problem also I can solve you using logistic regression. But remember, as the name suggests, is a regression problem. It is not a regression problem, it is a classification problem. You can say discrete classification problem. So to solve like yes or no type of questions, it is a binary. It can be used to solve as multi-class classification as well. So let's see, in this particular explanation we are going to concentrate more about binary classification. So okay, so I have taken one example. I have taken few weights of several people and categorize them with some, like this person is going to be obese or not. Supposedly I have taken like below 75 weights. Below 75 weights I have taken, like the person were not obese. So the person which are um, going to have more weight, like 76, 77, 78, I have considered it as obese. So supposedly, let's see, if I take as, as a linear regression, so I'm trying to find the best fit line and it comes like that. So yes, I can say, okay, so the middle person will come to like that, the middle part. So yes, I can say this is 0, this is not obese, and whatever the value comes as here, so I'll take the 1. So it is a obese one. So the middle part would be 0.51. So 75, if I take the standard one, 70, so it will come like that. 75 would be the standard one. So supposedly the new person the new person comes and has some 80 kg weight. So I can go like that, okay, 80 would be coming here, the 80 weight, and I can do project this to my best fit line as linear regression. And it will be predicted, it will be predicted here, and it will be projected y-axis by 0 point, like more than 0.5. So according to the linear regression, I can say here that the person, it will give you the probability, right? So if the person is going to have more than 0.5 value, so I can say this is a obese. Or any person have some 70, supposedly 70 weight, that person weight. So for 70, so this is the weight of 70, so I can project to my best fit line. It will come in the lower part of 0.5. So I can say this person is not obese. So whatever value goes off to 0.5, so I can mark it as obese, and whatever value that comes below 0.5, I can say not obese. But it can be solved, yes, as we have seen here, that it can be solved using linear regression as well. As you know that in linear regression, what we used to do, we just find the best fit line, and according to that, whatever uh, by the calculating the loss functions, we can predict our values. So supposedly, what one scenario came, and the person tried to weigh it as 200 kg. So 200 kg would be for 200 kg, for 200 weight, it will be projected as here. So it would be obese, but the 200 kg person will be predicted, will be drawn as here. So it will be, this particular outlier will be influencing our the best fit line. So the initially our best fit line was this, but after influencing such outliers, our best fit line will be like degraded, right? So it maybe goes like that, best, it changes our best fit line. So according to that, so if the best fit line changes, so what happens, uh, the ranges actually, the range of BMI, it will be degraded, as the person the more than 75 weight, the person more than 75 weight could be considered as not obese, right? So initially actually our principal rule was that it should be the 75 was the standard, below 75 it would be not obese, and above 75 would be the obese. But due to the outliers, it influenced our best fit line, and the best fit line would be degraded like that. So according to that, our standard also changed, because if you take more than 75, suppose 80, some 80 or 76, 77, whatever greater than 75 value will take, so it will become like it will come as less than 0.75. So this is how the outliers actually uh, degraded our best fit line, and it creates the problem here. So how, and another problem actually happens here is, supposedly it has no range, because it can goes up to like infinite negatives and also infinite positive, because we can increase our straight line very further. So there is no boundary here. But to solve this so it can be said that yeah, it has a high error rate, right? So to solve this type of problem, um, we have introduced the sigmoid activation function. So as you know, the sigmoid activation function, this is this is the linear line. So what we can do, we can take the linear, and this is the independent variable, as we know, and this is a dependent variable. So as you know, we have this is the linear line formula. So mx plus c, so these are the independent variables, right? So we can without directly perform this to our plotting, we can do one thing. First, before plotting the graph using this y, we can directly first we can directly put it to the sigmoid function. So after applying sigmoid to that particular function, we can plot the graph. So like whatever y value we have, we can put it to the like sigmoid function, and this sigmoid function will give you this type of graph. So it has some range. Like whatever the value goes as outliers, like different value, so it would be plotted as here, like 1 would be its maximum value. So it has some range like 0 to 1. So it has some range 0 to 1. This is one of the best advantage that we have. And also we can predict the probability of the ranges. So it will be easy to what to say, it is easy to find our probability. And so whatever outliers will come, so as it has some maximum value of 1, so it doesn't impact our predicting probabilities and predicting lines, right? So this is the ways, like actually it helps us in logistic regression. So in the next part of the video, we are going to clear understanding of geometric intrusion using maths in the logistic regression. So stay tuned guys. um, Thanks for watching.